welcome to Jinghua Education. I'm Steven. In this video, we're going to talk about Calculus 1, Limit Tutorial Part 16, Intermediate Value Theorems. Okay, every time we're talking about theorems on the book, we have a lot of well-written, very elegant mathematical languages. A lot of rules, conditions, and then which is not make sense. That's normal. Okay, that is what about advanced math is about. Okay, so I don't know why they're doing that, but my job is to show you to translate those kind of hard understand languages into a small simple examples. Okay, so what is intermediate value theorems? Thinking about, we got a river here. You have a river, okay, river here. And then this is you. On 1 o'clock, 1 p.m. you are in this side. And 2 p.m.s, you are in this side. Okay? You don't know how to teleport. You're just like a normal person. Then I can guarantee you what? I can guarantee you between 1 o'clock to 2 o'clock, at some point, you cross the river. Right? So you can hang out around here at the last minutes and then you cross the river. Or you can cross the river and then hang out around here or somewhere in between. You don't have a choice because you got to cross river somehow. Otherwise, it's impossible for you to be on the other side of the river. Okay, that makes sense, right? That is very simple logic. Okay, good. So that is the engine. That is the basic ideas about intermediate value theorems. So if some part we are finding a point, so the FA is less than a number. Somehow later we got a B point. The FB is greater than this number. That means between A and B, we must be some point to cross this value here. That is intermediate value theorems. Okay, let's see questions here. Okay, so what we're trying to do? We're trying to do, okay, so we're going to use intermediate value theorems to show the given equations at least, okay? Look this word, at least one. I didn't say it's one, okay? So 1 o'clock I'm here, 2 o'clock I'm here. I can be doing this. Finally I'm here, okay? I can cross the river so many times. So, but it's at least crossed once, okay? At least once. At least one are exactly one are totally different. Later we're going to show another one saying we just have to prove it exactly once. Okay, so there we talk about these things later. Okay, so at least one solutions and then indicate intervals. Note that you are not asking to find the solutions. We only show there is one. Okay, if you understand the intermediate value theorems, then it will be very easy. Okay, number one, we have to prove you don't know how to teleport. Okay, if you know how to teleport, our conclusion is not right. Right, you can be here, boom, you become here, and then in that case you don't have to cross the river. However, if you don't know how to teleport, what teleport means? Teleport means you are discontinuous function. Okay, if you don't know how to teleport, that means you are continuous functions. You cannot jump. Make sense? Okay, so that means we need to prove this function is continued. Of course it's continued. It's cubic function. Okay, cubic function is continued. We already proved that. We don't need to prove again. Okay, this function is continued. Okay, so this is proved. This number one conditions. You need to be careful. This guy is not teleporting. And then let's just put in -2 into this equation here. 25 minus 8 -2 square minus -2 cube. Okay, 25, this is how much? This is 32 minus 32 plus 8. Yeah, plus 8, that's right. We got how much? We got 1. Okay, that's 33 minus 32 is 1. Okay, that means when f -2 equal to 1. How about f4 is how much? f4 is 25 minus the 8 times the 4 square, which is equal to 16. And then plus minus the 4 cubed, which is equal to 64. Okay, so this is 89 minus 8 times 16. Okay, I don't even calculate that. That's how much. This is equal to 89 minus, must be bigger than 89, right? This is how much? This is equal to 108. Okay, so we got a negative number. Let's find out how much it is. It's negative 19, right? Negative 19. That means f4 is negative 19. F negative 2 is 1. That means at negative 2 part is on 1. On positive 4 part is negative 19. That means somewhere in between they have to cross and then make the entire thing equal to 0. Make sense? That means we already proved these functions continue, and then one side is the less than 0, the other side is bigger than 0. That means in between this interval they must cross 0. There is a point to equal to 0. That is how to prove the intermediate value theorems. Make sense? Good. You want to try yourself? You can pause the video now. All right, if you pause the video, do yourself, good for you. Okay, so I'm going to show you how to do these questions here. Okay, same thing. First things first, we need to prove this function is continued. Quadratic function, continue. Logarithm function, continue. We don't have any problem with the denominator, so we don't have any problem with discontinuities. So this is continue everywhere. Okay, that means we prove this function is not teleporting. Then we just put 0 in. F0 is how much? Just putting 0 into these w's will be 0 minus 4 ln 2, which is equal to negative 4 ln 2. Okay, ln 2 is a positive number, and then times negative 4, which is negative number. So it's negative number here. Okay, then f4 is how much? F4 is equal to 16 minus the 4 ln, which is equal to 22. Okay, ln 22 is nothing. It's not too much. It's like a 3 or 4 something. 3 something. Okay, so let me calculate how much is this. Okay, ln 22 is a 3.09. It will be 16 times 4 times 3.09. Okay, we can just say this 16 minus this is 12 something equal to positive number. Okay, because we have f0 negative, f0 equal to negative number. f4 is a positive number. That means between 0 and 4, we must have a point f, for example, c, a value c, which is making equal to 0. Okay, otherwise they cannot cross. Make sense? So between 0 to 4. Okay, in order to do the intermediate value questions, we just finding one side is bigger than 0, the other side is less than 0. So the middle point, there must be between these intervals, there must be a point to making the f something equal to 0. Make sense? That's how to using intermediate value theorem to prove function have at least one solution. We're going to talk about exact solution, how to prove that later. All right, so that's for today. Good. Okay, so if you have any questions, just comment below. I will answer your question in my next video. If you like, please subscribe. Thank you for watching.